In this video we're going to look at the sine rule. We're going to start off by stating the sine rule, and then we're going to prove it, and then we're going to look at an example. So let's start off with a triangle. And we're going to name the angle here large A, and opposite the angle is going to be the length, which will be small a. And we're going to do that for B and also C. So the capital letters A, B and C represent the angles, and the small letters A, B and C represent the lengths. Now we're going to state the sine rule, and the sine rule says that A divided by sine A is equal to B divided by sine B is equal to C divided by sine C. So remember, the small letters are the lengths and the large letters are the angles. Now we're going to prove this, and we're going to start off by dropping a perpendicular from this point here down to this line. So that means that we're going to create a right angle triangle here, so we can call this triangle 1. And we're also going to create another right angle triangle, which we could call triangle 2. And we can call this height here H. Now we're going to look at the sines of angle A and also the sine of angle B in terms of this length H. So we can see here in this triangle, the length opposite A is the length H. So this is the opposite, and this is going to be the hypotenuse. So we could say that H upon B is equal to the sine of A. And we can write this here. H upon B is equal to sine A. So therefore we can rewrite that as H is equal to B sine A. Now we can do the same for this triangle. We can see that the length opposite B is the length H. So this is the opposite. And that means that this length here is the hypotenuse. So we can say that H upon A is the opposite over the hypotenuse, which is the sine function. So we could say that H upon A is equal to sine of B. And we could rewrite that as H is equal to A sine B. So that means that H is this term here, and H is also this term. So it means that this term here must equal this term. So we can say that B sine A is equal to A sine B. Now if we want, we could divide this line side here by sine B and divide this side by sine B. And that would give us B sine A divided by sine B is just equal to A. We can then divide throughout by sine A, and this is going to give us B upon sine B would equal A upon sine A. So we have shown the first two parts of this. Now we can also go through the same thing in order to generate C divided by sine C. Now we could get rid of the perpendicular line, and we could get rid of the value H, and we could drop a new line from this point here down to this line. So that means that the large triangle will again be split into two. There will be one triangle here, which will have a right angle here, and we'll have a second triangle, which will have a right angle here. And we can rename this length here H. Now I'm not going to talk through the mathematics here of the proof. I'm going to leave that as an exercise, and you should be able to prove from this that A upon sine A is equal to C upon sine C. So that's the end of the proof of our sine rule. Let's go ahead and we'll use the sine rule in order to solve a problem. So let's say we started off with a triangle, and we were given that this angle here is 50 degrees. And the length opposite that angle is 12. And we were also given that this angle here is 40 degrees. And we're asked to find this length here. So that's the length we want to find. Now we can use our sine rule for this. If we say that this is the angle A, and this is the length A, and this is the angle B, and this is the length B. So we could say then that the length A divided by the sine of A is equal to the length B, which is what we want to find, divided by the sine of B. And now all we have to do is put our values in for each of these. So we're going to have the length A, which is going to be 12, divided by the sine of the angle A, which is the sine of 50. And it's going to equal the length B, which is what we're trying to find, divided by the sine of the angle B, which is sine of 40. Now we can rewrite this. If we multiply the right hand side by the sine of 40, then both of those cancel. It means we have to multiply the left side by the sine of 40. So we're going to be left with B is equal to 12 upon the sine of 50 times the sine of 40. So it means that when we put this into the calculator, this should give us the length of B. So let's go ahead and we'll put this in to the calculator now. So we're going to have 12 times, and we'll open up the brackets here, and we'll have the sine of 40, and of course make sure you're on degrees, and that's divided by the sine of 50. And it's going to give us an answer 10.069. So the length B is equal to 10.069. Now you can see here that if we're going to use the sine rule, then if we're given 3 terms, then we can always find the fourth. So for example, if we're given the length A and the angle A, and then the angle B, then we can always find the length B. Or if we're given the length A and angle A and the length of B, then we can find the angle of B. So it's best remembered via examples, and we're going to have a few more examples in the resources section.